Okay, let's see what we got going on here. This is 4.2. We're still doing transformations all chapter long. That's all this chapter is. That is the nice thing about geometry, is it just you kind of know what you expect from a chapter because it's going to be the same. This is going to be reflections. Okay, and unlike yesterday, I think we have all of one thing to write. No, that is lies. We got 4 things to write, but close. So see if you can find on page 164 and beyond. See if you can find line of reflection. Okay. At least in 2021, we're using computers for our assignments on this, but we still need to be able to do it in multimedia. Do we have enough room for our laptops and our books? It's a little yeah. Fortunately, these things start up pretty quick, so you can just close them. You don't have to leave them open, and they start up real quick. It's probably the easiest way to do it. All right. So line of reflection, we definitely need to know that. We definitely need to know what a glide reflection is. That's a fun word. I'll leave some room. And then we're going to pay attention to line of symmetry. And for some reason, I guess there's only 3 words. I was remembering, so for some reason they highlighted line of symmetry twice in your book. Maybe just because it's fun. That's what I'm going to go with. They highlighted it because it's fun to highlight line of symmetry. Maybe by highlighting it twice, they formed symmetry. I don't know. Okay. The nice thing about this book is pretty much everything important is highlighted, or they put in a little kind of core concept area, and then that's kind of like since we're at Choctaw, I'm going to call it a Vegas gold tint, but I guess it's like beige or, spoiled mustard color. I don't know. What did you call that color?
What is up with you in the words Vegas gold?
That's the official color of Choctaw.
Oh, really?
Is blue and Vegas gold.
You said it so many times.
Yeah. It's so we don't do that anymore now. Now you can have black and you have various blues and various golds, but old school Choctaw, it is. I think they call it Choctaw blue, even though I think it's some other kind of blue. But they call it Choctaw blue, Vegas gold, and white. Those are the official old school colors. Vegas gold is not a very attractive color. Fortunately, nowadays, when they go for uniforms, they try to make them look good. Like even the band's uniform nowadays, what color is the band uniform? They're red. Because it's all about the show a lot of times. And so the cheerleaders, what color are the cheerleaders? They have a blue uniform and a black uniform. And then, of course, football players have all kinds of different.
They have a black uniform now.
The black uniform.
For this week, this next week.
They have a white uniform. They have 3 helmets, I think, right?
Yeah, black, gold, and white.
Yeah.
And then the black uniform, white uniform.
And since we got all fancy with the golden helmets, we can't do the Vegas gold pants because it would really clash. It's really, really terrible together.
Yeah.
If I can find some old pictures, I will, of the uniforms. They'll probably be in black and white because, you know, they're old. That's closer. Yeah, that's about what Vegas gold is on that. Just imagine that, but less shiny.
Yeah, because you're a Jesuit and you were like, "Dude, what are those coaches? Are they like Vegas gold?" And because you thought they were all just.
Yeah.
That's funny.
I thought we were doing some retro throwbacks.
And then it turned out to be
What are you mad about? You want included?
In what?
And then retro throwbacks?
No, I'm good. I'm retired from the coaching gig, so I'm good. Line of reflection. All right, I have a one-word definition of line of reflect. Wow. And they use the same thing. They call the line of reflection a mirror. Right? That's the best definition I've ever heard. Okay, glide reflection. I like a glide reflection. That sounds like it's fun. Let's see. Glide reflection is a transformation involving a translation followed by reflection. Okay. So first, translation, and then a reflection. Okay, line of symmetry. You know, a lot of these are common sense. A figure in a plane that has a line of symmetry when the figure can be mapped onto itself by a reflection in a line. So basically, mapped means kind of drawn onto itself. So basically, I can draw like a little shape here. Let's draw a little shape. Okay. So if that's my little mirror, and there's my line of symmetry, that means on the other side, let's see if I can duplicate it. That's not very good. I'm trying. You know, that would be a line of symmetry where basically this half of the shape is staring at this half of the shape, and it's the same. Okay? So we're going to look at that. Here's the nice thing about today's notes is this is the main, most important thing there is on it, and that is on page 165, and that's rules, okay? That is rules for where we're drawing the mirror. Okay, and I like to draw this, so they write it in if-then form, which is nice. It's kind of like theorems, and I'm just going to show you where we're talking about. It's kind of like theorems, but it's not. But it's still an if-then form. Okay, and so this is dealing with points. And I'm going to kind of show you how this works before I set you loose. So you take a point. If the point is reflected on the x-axis, then its image point would look like this. So go ahead and write down this formulas in your thing. And this is basically the last thing we're writing down. And then I'm just going to take some points and make sure you can do all these things with it. Now, I'm going to show you another trick because the mirror, the line of symmetry, or the line of reflection can be different places. For you guys, we're going to do the x-axis to y-axis, y equals x, y equals negative x. I'm going to go over what those look like. We're also going to sometimes move the mirror, and I'm going to kind of show you what you need to do on that. And I'm going to use my graph paper on that, and then you're going to, in 2021 anyways, you're not going to use graph paper, you're going to use the computer, which is easier because it will tell you if you're right or wrong. Okay. Of course, if you're at home, you can just pause this and get it, or you can look it up in the actual book. All right, I need to... Draw some little things here, and I guess in 2021 it's Friday Eve, isn't it? My favorite day of the week. And if you're bored, I think there's a volleyball game tonight. I think it's senior night. Which is always fun. Okay, I'm going to show you how to use these formulas in just a second. Once you can use these formulas, it makes life easy. Because there's two ways to do this kind of problem. Sometimes you can look at it and do it, and I'm going to show you the looking at it and doing it part. And sometimes it's not working for you. The looking isn't working for you, so you actually have to go ahead and use these formulas. And so... Also, sometimes you look at it and it says, that doesn't look right, so you use the formulas to check it. And these are not hard formulas. Basically, all you're having to do is change the sign. This is not going to be a memorized thing either. I'm not going to say, hey, memorize all these things. We're going to be able to look at some of these things. Okay. All right, here's my point. I am going to reflect this. I'm going to make the x-axis the mirror. Okay. So I'm going to reflect this about the x-axis. What the formula says is that if this is the point, then its image is the point A, comma, negative B. So this is A, B. So what would A, comma, negative B be? Would it be just this? Is that all I have to do on the formula? Okay, let's do something harder. Let's do this. Negative 6, 8. I'm going to reflect this on the y-axis. The formula says what? So it says the formula is supposed to be negative A, B. So what do I do? What? Doesn't stay the same.
6, 8.
6, 8. One way to look at when it says negative, it's a negative, sure. Another way to look at it, it means do the opposite. Do the inverse. And so the opposite of negative 6 would be 6. And that's why I'm going over this. Okay. The AB stuff is a little bit more difficult. I'm sorry, when the line of symmetry is this, it's a little more difficult. And I'm going to graph this so you know what it is. So AB would be, well, I don't need to do AB. That's the formula. Let's just do negative 7, 6. What would it be here? Well, it looks to me like I'm supposed to just basically flip the order, doesn't it? One could even say maybe it's the converse. I don't think that applies here, but maybe. Is this the answer? So that's how you use those formulas. Not a lot of work, is it? Although this is kind of a handy little chart or handy little thing to look at while doing the work. That way we don't have to have a book out also. All right, I need a graph just so you remember what y equals x is. Okay. I'm going to rewrite that. That's terribly close. Y equals X. Okay? Well, this is very simple. What this ends up being is the B equals 0, so the y-intercept is 0, and the M equals 1 over 1. So this is what that would be. Okay, and so what I'm going to do when we graph like this, I'm going to just draw a mirror like this. And we'll see if you're allowed to draw a mirror on your assignment. We'll see. So that's what that one looks like. What do we think this one would look like? Would it look like this?
Yeah.
Okay. These are the, as far as non-vertical horizontal lines, these are the only ones we're going to do. Okay, one of the difficult things to do reflections, and I'm going to kind of show you this. We're going to try to punch in right here. And I'm going to kind of show you how reflections work. So let's not do a difficult one. Let's just make the x-axis the mirror. Okay, let's make the x-axis the mirror, and I'm going to draw a shape like this. It's a very exciting, happy little triangle. And I can use the formula. Okay, so I'm going to use the formula for 1 point, and then I'm going to use my eyeball for 1 point. So let's see what this point is. This point is like 1, 2, 1, 2, 3, 4. So this point is 2, 4, right? The formula to reflect it about the x-axis would be what? A negative B. Okay? Can you see that? Yes. So I'm supposed to graph 2, 4. Okay? So that would be 2, negative 4. 1, 2, 3, 4. All right. So this would basically be A, and this would be A prime, because this is the pre-image, and this is going to be the image. One way to do this is just to count. This is an easy mirror, right? Okay, so if I'm reflecting on this image, this point is how many away? Let's see. 1, 2 away from the mirror, right? So that means the other point is going to be 1, 2 away from the mirror. Call that B, and we'll call this B prime. This is how far away from the mirror? 1, 2, 3, 4. So I'm going to put it 4 away from the mirror. 1, 2, 3, 4. I'm going to call that C, and I'm going to call this C prime. I'm going to connect the dots. And does that look like a mirror image? So we can use the formula to help us check it. We can also look at it and count. That is okay, because this is a real thing, right? Okay. These mirrors are harder to do that with. It's harder to see how to count because it's a diagonal line. All right, we are going to have some mirrors that we're not going to necessarily be able to use the formula with. I can actually give you a modified formula, but I usually don't like confusing people because it's almost easier to do this. Let's say we have a mirror of x equals 3. Where is that mirror going to be? 1, 2, 3. Is this x equals 3 right here? Okay, remember it is extreme. It has an extreme slope. So there's the mirror. And so like if I had a shape over here, I'm going to draw this shape real quick. Uh-oh. This shape crosses the mirror. Is that okay? Okay. I am not a big fan of what I did with this shape. So I'm gonna do this again with a shape that is not going to be as confusing. You will have to do this sometimes where the shape does cross the mirror a little bit. This shape will be a lot friendlier. And so just seriously, just look at this. If this is the mirror right here, this point is 1 away, right? So this is let me write this down. This is A, B, C. That is the pre-image. And so that's 1 away. So then the image would be here. Let's see, this is 1, 2 away. This is 1, 2, 3 away. 1, 2, 3 away. Okay, is that okay? It's still a reflection. So notice A starts on the left, goes to the right. B and C start on the right, go to the left. That's basically it. That's all she wrote. I'm going to stop this video and